Still the moderator. Now we're moving on to a section which includes something at any rate on child mortality and not exclusively child mortality. Can we all settle in, please? Hello? Quick. Oh, I'm too old to tolerate. What? It's great. So we're starting with Danzhen talking about analytical approaches and multiple data sources, familiar theme, in the evaluate the completeness of infants and neonatal mortality in low and middle income countries. Danzhen, you have the floor.
So this presentation is based on the work of the UN Interagency Group for Child Mortality Estimation, which is called UNICEF. And I would like to thank Lucia, who's in the back, and also Michel, and also Michel, as well as John Patterson, who contributed to the UNICEF work and also this presentation. So very briefly about the UNICEF, for those you don't know about the UNICEF, it was formed in 2004, including UNICEF, WHO, and World Bank, and the UN Population Division as 4 members. And 3 main areas we are working on. The first one is to produce child mortality estimates for global monitoring and reporting. And the second is the methodological development. Third is country capacity building. And all the information about the group and its work can be found on the website, childmortality.org. So this presentation really focuses on the child mortality data evaluation based on the IGMI experience. Here we are going back to the basic method. So before I talk about the methods we used, the main key issues for recording births and deaths for children under age 5 can include I listed 4, but maybe more. For age misreporting and the displacement of births and deaths, which we will call age heaping, and also on the reporting and omission of births and deaths. And the last but not the least is the misclassification due to different definitions used or other reasons. So based on the UNICEF experience, we kind of grouped the methods to 2 groups. One is cross-checking, and the other one is internal checking within VR data. So the cross-checking, we can make comparisons to other data sources, and we can also make comparisons to standard patterns of child mortality in other countries. And for internal checking, we can look at the age patterns as that. We can look at proportions, look at the ratios of mortality rate, and also the number of deaths by day and by age to look at the age heaping. For proportions, for example, the proportion of early neonatal among neonatal deaths can really tell us whether the early neonatal death has been underreported or not. So it's more common to report the early neonatal death than in the older ages. And for the ratio, we can look at the ratio of stillbirths to early neonatal mortality rate, because there's some misclassification usually happens between stillbirths and early neonatal mortality rate. So these are very basic demographic techniques that we can apply to check the quality of child mortality data. And then we can look at the differentials in mortality across sexes and across urban and rural areas and subnational regions. But here, I won't show this part. I will mainly focus on the cross-checking and the internal checking for age patterns. But I'm sure Michel has covered for the differentials in mortality in his presentation somehow, and probably others also covered already. And based on the economic experience, we really want to highlight the importance of understanding the registration legal framework and also definition used for live births, stillbirths, and infant death, and also the data reporting flow. And we think this can really help us understand how the system works and therefore also understand the quality of child mortality data. So for cross-checking and internal checking, because they are usually used together, so we will put together. So here's one example for flu. The chart shows on the biomortality rate from all the available data sources, including the vital registration data, which appears at the bottom. So you can see, so here, this line is much lower than all other data sources on the biomortality rate. And this is a zoomed-in chart from 1990 to 2015. And the other example from this time, which you can see the black line, also VR data, is much lower than other data sources. And here we have one DHS direct estimate and also indirect estimate, those dashed lines. Based on some data quality assessment, we found that this data has some data quality issues. So you can see, indeed, it's even lower than the VR data. So these are comparisons with the data sources available for the country, at the national level. And we can also compare to other countries to standard age pattern. For example, here we show the chart for Sweden and Uzbekistan for the proportion of early neonatal deaths among the neonatal deaths. So the y-axis shows us the proportion of early neonatal deaths among neonatal deaths, and the x-axis is the infant mortality rate. And the red line is for Uzbekistan, and the dark blue is Sweden. So you can see the proportion of early neonatal deaths among neonatal deaths are systematically lower in Uzbekistan than in Sweden at a comparable infant mortality rate. And also there's some convergence towards 2012. And similarly, this chart shows us the relationship between neonatal and the post-neonatal mortality rate in the two countries. And also, you see systematically lower neonatal mortality rate at the comparable post-neonatal mortality rate. So one possible way to adjust the neonatal mortality rate is to adjust to the Uzbekistan neonatal mortality rate upwards to Swedish level for comparable post-neonatal mortality rate. By doing that, we assuming no omission of deaths in the post-neonatal period, and also assuming the age pattern are more or less similar. And this chart will put all the available data together for the ratio of neonatal mortality rate to infant mortality rate by infant mortality rate. So the vertical axis is the ratio, and then the horizontal axis is the infant mortality rate. And here we have different color coding, which means denote different regions. The blue dots are for countries with functioning vital statistic systems, and the red one are the Central European countries, and the orange one are Latin American and the Caribbean countries, and the light gray are small countries, and dark gray are all the Asian and the African countries. For those other Asian and African countries, we do not have a lot of data. And from this blue dot points, you can see with mortality decline, there is an increase in the ratio of neonatal deaths and neonatal mortality to infant mortality. And this can be clearly seen when we zoom in the chart. So this chart is the same chart, but we just show the infant mortality level from 0 to 60 deaths per 1,000 live births. So here you do see around the infant mortality level of 20 or 15 deaths per 1,000 live births. In some countries, the proportion of neonatal mortality rate to infant mortality rate starts to decline. And this is not only in one country, it's observed in many European countries. But you also notice the most, for those blue dots, the majority of the data points are all above 50, above 0.5 or 0.6. This is for the ratio of neonatal mortality rate to infant mortality rate. And apparently for Central European countries and also Latin American and Caribbean countries, you see a lot of, you see much lower level in this period. There are many more data points from these regions. We can think of probably two reasons. One is the data quality issue on the reporting, its classification, mission. Second, maybe the age pattern has been changed, but it is unlikely. We know this region, in this region, the CRPS system is incomplete. Just to add one point, for small countries, we do see a lot of variations also here, because they're so small, so we see a lot of variations. And similarly, we put the ratio of early neonatal mortality rate to neonatal mortality rate. You see less variation from this chart. It's just due to less data points available, because we don't have a lot of disaggregated data by the first 7 days. For those developing countries, so you do see this with more concerns about it. It's just due to the reason of lack of data points from developing countries. So here you can see the ratio of early neonatal mortality rate to neonatal mortality rate also started declining at a certain level for some countries. And the majority of the data points are above 0.7. And I think Connie did some analysis for Western European countries. On average, it's 0.77, something like that. And also, based on some study on DHS and the mixed surveys, this is also around the 0.7 for developing countries. So it's a very high proportion and the ratio. So apparently, Egypt, when we look at the this is 2 data points for Egypt in the year 2012 and 2013. Seems like they are outliers. And if we look at the ratio, it's really low for both the proportions and the ratios. For example, the proportion of neonatal deaths occurring in the early neonatal period is only around 40%. And compared to 0.7, which is really low, and especially for Egypt, the mortality rate is already quite low. So here, compared to other data sources for undefined mortality, we do see slightly lower level from the VR data. But if we look at neonatal mortality rate, it's 50% lower than other data sources for the VR data. So now I just want to show one example from Guatemala. Guatemala, you can see that for neonatal mortality rate, they are consistently lower than other data sources, but not for the undefined mortality rate. So something different for the two indicators. So we do need to look across indicators. And Guatemala, if we look at the proportion over time, this is the other way to show not by mortality rate, but over time, by time. And then we see, compared to other countries, Guatemala also has a very low level for the proportion of infant deaths occurred in the neonatal period. And also interestingly, we observed this sharp decline, sharp drop after around the year 2007. So this proportion is the proportion of neonatal deaths occurring in the early neonatal period. So something happened after 2007 for the early neonatal deaths, whether it is the intervention of the government to save, newborns in the first 7 days, or whether it's data errors. I think it's probably likely to be the data errors, omission or underreporting. One more example for misclassification of early neonatal deaths. This is the Czech Republic. So if we look at the proportion of infant deaths occurring in the neonatal period, we do see a flat line here, and the level is not so low compared to countries with well-functioning vital retracing systems. It's in the lower level, but lower bound, but not really too low. However, if we look at the proportion of early neonatal deaths among neonatal deaths, then you do see some deterioration in the proportion, getting lower during this period. And according to some analysis, also there's a European report on the definition of the definition used for prenatal and also stillbirth neonatal infant deaths. They are different from the international standards. So this is really a misclassification issue in Czech Republic. I think that's different from Haidong's presentation that you think the registration is complete. And we adjust for 10%, probably. I forgot the exact number. To measure misclassification, because misclassification is very common for early neonatal deaths to be classified as stillbirths. Then we can also look at the ratio of stillbirths to early neonatal deaths. This is one example from Pakistan. You see a sharp rise in the ratio after the year 2008. In the year 2008, Pakistan fully implemented the international definition of live birth. After that year, after the first year or couple of years, there's some backsliding from use of the international definition. And this has been confirmed by our contribution a few years ago. And now I really want to highlight the importance of registration to understand the registration legal framework, definition use, and also the data source and reporting flow. This is not some demographic methods, but I really think, based on our contribution experience, it's really helped us understand the picture, or the broader picture behind these data points. We can understand why this happens. So I just want to highlight that. And for legal framework, we can really, by understanding the legal framework and the requirements, we can identify obstacles to registration. For example, if there is a fee, people may be reluctant to go to the registration office to register the birth and death. And also, to register birth, if a marriage certificate is needed to register the birth, and this is the case for in some countries, then you might also not be able to register the birth for single mothers. So all this legal requirement framework will really help us understand the data points. And also, I want to note that the registration practice indeed might be different from laws. For example, in I think I think the international definition of live birth has been included in the laws, but not in practice.
Kazakhstan as well.
Yes. Yeah. So we had a mission to those countries and found these issues. So we understand why the VR is really quite low, quite lower than other data sources. And the definition issue we mentioned due to different cut points for the weight of the birth and also the duration of gestation, you may have countries may use different definitions, and apparently will result in different level of mortality. And also understanding the data reporting of the flow, like whether the medical system, health system also reports to communicate with civil nutrition systems, both in the sectoral collaboration and also commitment of government. These are also very important to understand how the system works, therefore the data produced by the system. So here's one example from Mongolia for the flow of administrative data. So here we have three systems. The blue one are the medical registration system, which indeed are doing a very good job in Mongolia to capture birth and death registration. And then the orange one are the civil registration system, which is not doing a good job to capture birth and death registration. And in the middle is the national system. So, and you can see also here this dashed black line links to be established. That means there are missing linkages between these two systems at the district level. They don't communicate. So they don't share information, they don't talk, and everything captured in the medical system, they don't share with the civil registration system. So these are the system and how the system works and coordinate and collaborate in Mongolia. And you can see from this table, the live births here from the National Center for Health Development, and the population estimated or adjusted by the National Statistics Office are based on the household registry. So here, recorded births are consistently higher than the population on the 81, which is, it's much kind of implausible at this level. So really confirm also the medical registration system is doing better than the registration system. So Mongolia, the registration system also improving the coverage for death, and you can see that it is some increasing the infant mortality rate, but likely because of the improvement in registration. And for the registration data is lower than other data sources. And very quickly about strengths. So these are diverse methods and a very simple method is what we can use. And I think at the country level, probably those technical people very easily can understand using these ratios, proportions. And also, many of the methods can be applied to subnational estimates and also for estimates for subgroups. And these methods are able to identify age-keeping, potential omission, and misclassification. And the limitations are also very clear. We need detailed information. For example, the number of deaths is aggregated by day, month, age, and by sex, by residence, by region. And secondly, also, it is very difficult in defining the exact levels of omission and incompleteness, misreporting, and misclassification. So need more research in this area. And then I think many recommendations we can make for national authorities, but here a few are selected here. Definitely we need to create incentives and new barriers to register birth and death, and probably also use innovative tools, and UNICEF developed many tools for birth registration. And countries need to adopt standard definition and also standard reporting format for reporting annual mortality data. And also the evaluation of the system is quite critical for the government themselves, also for others to understand how the system works. And the censuses and household surveys can be used as validation sources, not only by adding the mortality module in censuses or the household services, but also can add validation questions on birth and death situation. And I think Ken in the morning already mentioned we should use multiple data sources and multiple methods to evaluate CRBS data, and then make a detailed birth and death data available as open source. And this is really important in the context of the SDG, which is calling for this aggregation for all indicators. And the last thing not the least on the reporting is more common for neonatal deaths, particularly early neonatal deaths. And efforts should be made to capture these deaths. And this also becomes increasingly important given the increasing proportion of neonatal deaths among under 5 deaths, and also that the neonatal mortality rate now is SDG indicator. So I think I'll stop here.
Excellent. Thank you very much, Danzhen. To move on to a rather similar theme, Michel, international lessons learned with the application of indirect methods for the evaluation of independent death registration in Central Asian republics by subnational characteristics.
This title is a little bit shorter than the
to make it easier.
This presentation is just very nicely after Danzhen's presentation. I'm going to talk a lot about some of the issues that she's already covered. So I'll go a little bit more quickly on the slides. I'm going to be talking about H11 as well, and I'm going to be speaking about yet another dance. This is basically a paper that is published a few years ago on this study, and you have a version of this paper available on the website of the conference. So a few years ago, I conducted a study of infant mortality in Kyrgyzstan, and this was a study in collaboration with the National Statistical Committee, National Statistical of the Kyrgyz Republic, and we had a very specific research question that we wanted to ask to study. What was the impact of the breakup of the Soviet Union on infant mortality based on IMR patterns? So the context for this is that the vital registration information indicated a continuation of prior declines in infant mortality after the breakup, which happened in January 1991. And the question was this decline real or due to a decrease in coverage? So we used all available sources to try to answer this question, including detailed VR information. So the main purpose of the study was not to directly evaluate VR information. VR information was one element of information that we used. But as part of the study, we identified some problems with the VR data and adjusted for these problems. So I think this is a one-country study that we did, but I think there are some lessons that can be learned with potential implications for other countries, and I will talk about some of these lessons at the end. So this is the information, the VR-based, uncorrected and adjusted VR information for Kyrgyzstan, and in comparison with Russia. You have Russia in red and the white circles for Kyrgyzstan. And the focus of this talk, I won't say on infant mortality, because this is what they care most about, and we could do the same thing for under 5 mortality. Just the pattern is pretty much the same. But I'll be talking only about infant mortality presentation. So you see no visible impact whatsoever in Kyrgyzstan of the breakup of the Soviet Union. You have very short declines in the 1980s, and then continuation of the declines through the 90s. And there is a reduction of the gap between Kyrgyzstan and Russia during that period. And the question is this real, or is it due to bad data? The second increase in 2004, which I'll talk a little bit more about later, this is related to this change of definition, like Danzhen has shown for Kazakhstan. So one thing that was clear when we started the study is that the reported levels of vital registration infant mortality published by the vital registration data were too low. And this was clear when the first DHS for Kyrgyzstan was published in 1997, where the IMR was basically twice as high. The direct estimation of the IMR from the DHS was twice as high as the vital registration. And this really came as quite a shock at the time because this was really the first time these kinds of surveys were done, and so the National Statistical Office really reacted quite shocked at that time, back in the 1990s. And they are too low. The VR-based infant mortality are too low for the following reasons. The Danzhen touched upon these. There is this issue of the subject versus the W definition of live birth versus still birth. The W definition is more inclusive, so it's basically more live births that can deaths that are included. So the subject with the subject definition, you have too low an estimate of infant mortality. But you also have just overall undercount of deaths below age 1 and their corresponding birth, even those that do meet the subject definition. And there is also age-based reporting of death, especially for infant mortality. You need to have a strict cutoff point of exactly the first birthday to be able to make a distinction between infant death death occurring above age 1. And then one issue that I'll talk a little bit about, which is actually a big issue in infant mortality. It doesn't matter when you look at infant mortality rate at the national level, but when you look at by urban-rural residents, there is quite a big problem with misattribution of residents on the death certificate. So I'll talk about that a little bit. So as a first step in our study, we looked at the internal consistency of racial distribution data, and some pretty implausible patterns emerged. First, and this is all unadjusted VR data. So if you look by residents, you have the urban infant mortality in blue and the rural in red. And during the late Soviet period, there was this excess infant mortality in rural areas as expected, but suddenly over 1990s crossover, and suddenly the rural infant mortality looks lower than the urban one, which the local researchers in the National Statistical Office attributed to fresh air in rural areas. But this is only one of the possible patterns that we see here. And then if you look by ethnicity, what's interesting is that Kyrgyzstan is a multi-ethnic country, and you have basically two main broad groups. You have Slav, Russian, Ukrainians, etc. Then you have Central Asians, mostly Kyrgyz and Uzbeks in Kyrgyzstan. And during the late Soviet period, you have this excess mortality among Central Asians. That's not very surprising given the higher level of poverty that you find among Central Asians, Slavs in the region. But then during the 1990s, you have sort of an narrowing of the gap, and the reported data starting in 1995 is no difference by ethnicity, which also is surprising. And then if you look at the data by month, and this graph shows the monthly probability of dying during the first 2 years. If you look at the blue line, that's the one that was the process of the most clear, is for 1983. You see an initial decline in the probability, but then the monthly probability of dying, but then it increases again to age 3, and it declines, and then you have again an increase of this age shaping around 12 months, which is suspicious. And basically these two, basically what we can suspect from this graph is that there is quite a bit of underestimation during this period, and then there is this problem of 12 months. Are these deaths that are migrated from the first year to the second year? So local studies suggest that this is the case, that there was this practice of trying to push up a little bit some of the neonatal deaths toward the second year, because hospitals and regions, particularly where run based on IMR, and so kind of a way to make the IMR lower than the same way. So this shows clearly in 83 this disappears. Later on, look at this graph again. So anyway, this is clear that the VR data in Kyrgyzstan has some cues from as is. So to evaluate the IMR trend, we used all the possible sources. So we have DHS, one DHS put on before there's a new DHS now that exists, but at the time it wasn't available. So we DHS, from which we do direct estimates. We have a mixed survey, from which we derive indirect estimates, and we also had access to the 89 and 99 census. And then we try to make use as much as possible of the vital registration data. And we basically try to adjust it. And the reason is that we were interested in these short-term trends, and that's one problem that we have with survey data with these methods, that they're not very specific in terms of being able to detect these annual fluctuations or stagnations or slowdowns. So we wanted to see if we could do better, and also we were interested in subgroups. And as you know, especially for small subgroups, direct DHS information or graph indirect estimates are difficult to capture differentials. This is the approach that we use for correcting our data. We use information on death by month of age, and this was based on unpublished information that we obtained from the National Statistical Office. And basically what we calculated was 21Q3, and that is in months. That's the probability that the child who survives to age 3 months will die before age 24 months. So why did we use 21Q3? We used it for the following reasons. Basically, what we can see from basic demographic methods is that the reported 21Q3 will be unaffected by definitional problems of the microstatistic level. That's not going to be affected at all. It is not going to be affected by undercounts of deaths below 3 months and the corresponding births. And it's also a measure that is not affected by whatever age this reporting is occurring between 3 months and 24 months. So any transfer within that age range is not affecting that observed probability. It's not a perfect measure, obviously. This reported level of 21Q3 is still going to be affected by undercounts of death between ages 3 and 24. But the idea is that most of the problems identified in the VR data are occurring age-heating problem and what happens in 3 months as well. So we believe that 21Q3 is going to be a better measure facing these problems. And we also take advantage of the fact that there is a strong relationship between 21Q3 and IMR. Danzhen showed some graphs already. And the idea is that we're going to be using this relationship to adjust infant mortality rate on the basis of the reported 21Q3. So, and for this we use data from Sweden and Minas. Sweden is one of the peers each pattern. We have also data from England and Wales. This is the relationship between 21Q3, so the probability of dying between 3 months and 24 months, and the infant mortality rate. And as you can see, in both countries, Sweden, England, and Wales have a very similar relationship. But if you see a very strong relationship also, and if you look at Kyrgyzstan, however, the red dots, way below the curve, at least up to a certain point, top of the level happens at this point. But this suggests that there is an important underestimation of the infant mortality rate in Kyrgyzstan due to both age heating around 12 months and issues under age 3 months. So the idea is that we're going to be using this relationship and predicting the level of IMR on the basis of the observed level of 21Q3. And we're going to be comparing this adjusted VR estimates with other sources. This is not a new approach. This has been versions of it have been used before. So there's a paper by Kincaid and Arriaga in 1987 that did a similar correction, though they used mortality between 4 and 10 months as an anchor. Here we're using a bigger age range, so we're using more information here for the prediction. So here are the different estimates that we get. So you have at the bottom the unadjusted VR, then the points that are connected at 2 or 4 points together, whether it's a survey or DHS or census estimates. And then in red, the long-time series here is basically the adjusted VR estimate in this procedure. And what we are showing here is that the adjusted VR estimates are very comparable with the survey of census estimates for the years when they overlap. We are showing about the validity of the approach. But the advantage of using this adjusted VR here to look at patterns and trends in mortality in countries like Kyrgyzstan is that here we have an annual time series for a long time period. We don't have 22 points. We have data for the more recent period, which was not the case at the time in terms of survey data. And then we see patterns that were actually not detected in survey data. And I think what an important point here is that we observe stagnation in mortality rate versus prediction in 1990. Only starting in 1999, there was a zooming of the decline in the mortality, and this would not have been apparent by just survey data. So skip this because this is what I just said. But there is what we do conclude that's important is that there is a deterioration. We conclude about a deterioration of quality in information. Now let's look at the outcome of this adjustment procedure by residents. So you have for urban by residents for urban and rural areas. Same approach. We have the unadjusted rate and the adjusted ones. The red dots. The adjusted procedure are pretty consistent with the survey data, but the most important decision that we see is that there is no, once we look at the adjusted DR data, there is no crossover between rural areas anymore. So it looks like fresh air was indeed not partly helpful for rural areas in that period. And then we also make some estimation about this issue. Part of the problem is actually this misattribution of rural to urban, so rural deaths that are misattributed as occurring in urban areas. And we actually do conclude, and we do some calculations, and we conclude that 40% of actual rural infant deaths are misattributed to urban areas. We can look at this by ethnicity as well. And what we see is that when you look at slabs, there's basically no difference. There is very little difference between the adjusted and the non-adjusted DR data. And it's all consistent with the survey or census. However, there's a big difference for Central Asians. The 21 Q3 adjustment, the data are more sparse. Many years the babies will be adjusted. What you see here, the conclusion that once you do this adjustment, you don't see the narrowing of the ethnic differential. And basically what we concluded is that there is larger underestimation of infant mortality among Central Asians, which is what I just said here. So now there's this change of standard for classification live birth, and this happened in 2004. And as a result of this change of standard, there is a 42% increase in the reported IMR between 2003 and 2006, which we saw in the initial graph showing the unadjusted IMR trend. So this is actually the test for this adjustment because the 21 Q3 based IMR estimate should not be affected by this change of definition if the premise is true. And in fact, as you can see here, you have this increase in the unadjusted and basically when you look at the 21 Q3 adjustment, there's a little bit of stagnation, but the two theories align, which is supportive of the fact that the adjustment that we made did in fact take care of this definitional problem. And this is particularly visible in the comparison with the treatment and treatment in the relationship between 21 Q3 and IMR. You have the red dots for Kyrgyzstan here that are too low, and then this is exactly what happened. This point here, this is when 3 points is how the relationship changes once the new standard, the WHO international standard, is adopted, and that basically brings the red dots, the observed dots for Kyrgyzstan, becoming aligned with the standard for Sweden. Wales, which is also supporting the idea that whatever gap was occurring before was due to the issue of definition, not only and then once adoption of standards is placed, Japan and the relationship between IMR and 21 Q3 are exactly the same as Sweden and Wales. We did the final adjustment here. This was a little bit ad hoc. I would do this differently if I could. Again, probably quite K3 model, but we did realize that our 21Q3 still produces series that were lower than the direct estimates for DHS in 1987, which was suggestive that for the reported level of 21Q3 was still slightly underestimated, about 10%. So we just pushed all the estimates up 11%. But this was a bit ad hoc, but it was in recognition that there's probably still some underestimation of mortality in the age range 3 to. All right, so the main findings is that contrary to what registration data indicates, the infant mortality rate abruptly stalled in Kyrgyzstan following the breakup of the Soviet Union, and the infant mortality remained higher in rural areas than among population ethnic groups. In terms of the quality of the VR data, what we conclude is that there is deterioration in the 1990s, especially in rural areas and among Central Asian ethnic groups. However, there's been an improvement since 2004 in relation to the change of standards, but we conclude that the reported IMR in 2010 is still underestimated by about 11%, and in fact, the new DHS data that came more recently is supportive of this conclusion. In terms of the lessons learned here, so in the area of actual registration estimation, so the poor quality of the VR registration of the VR data on infant deaths in Kyrgyzstan was not systematic but concentrated at some ages. And I think that's an important point here, that certain age ranges that were of higher quality and could be used to adjust IMR using mobile standards. Approach produced the right as well for years. And the advantages of trying to correct the VR data is that first, we could detect a time pattern that was not at expectation. We had more up-to-date information as a result of this adjustment. We could do some estimation by subgroup. With the DHS data, you just cannot make slabs. There's just a few slabs remaining in slabs. But I think an important point here is that this adjustment was based on locally produced data. Food and local data. We did this adjustment together with the National Statistical Office. The National Statistical Office, confronted the data quality issues. The errors could not be ignored, especially when they looked at subgroup data and age-specific data. It's one thing to say, yeah, the overall level is believe in it, but then when strange patterns, and they have to confront this problem. But at the same time, the National Statistical Office was reassured to see that the VR data did not need to be completely discarded, that there was some information that could be taken from it and that was sufficient for an adjustment. And so that was something that I think they felt empowered about. And this also helped them with strengthening their GRBS, especially in terms of, by the time at the end of the study, as you see, the VR data was much better, but there was still this issue of urban-rural distribution, which they realized as a study. Remaining issues in terms of trying to make this a little bit more general, the model was the age pattern model was very rudimentary, based on only two newer conditions. It worked well in Kyrgyzstan, where problems were consulted at very young ages, but how generalizable, how often do we have this kind of data configuration? And also the approach did not address certainty around adjusted estimates. So here are some ideas for future research and recommendation. So we want to like to expand the model age patterns using a wider range of high quality data, not only Sweden and else. We want to explore other entry points besides 21Q3 that may be more relevant for other data constances for other countries. We want to address uncertainty, and then we want to examine which countries outside the former Soviet Union most benefit from such an approach. And also, I think Danzhen mentioned that as well, like to encourage national statistical offices to publish more detailed age-specific information below each slide. There's a lot of information that we can derive, useful information derive age breakdown. We have a research proposal pending, which hopefully will get funded and will allow us to fulfill some of these tasks. So that's it. Thank you for your attention.
Thank you very much, Michel. Okay. Next we have Rob again, talking about South Africa. National and subnational experience with estimating the extent of trending computers and registration research in South Africa. Rob.
I must warn you, it's way past my bedtime in South Africa. I'm not sure how this is going to work out. I also declined to have my notes printed out because I thought it might go quicker if I didn't remember what I wanted to say. I'm briefly going to be looking at four areas of research that we've been busy with in South Africa. The first is the rapid mortality surveillance system, which makes use of the population register, again, hopefully convince more people that it's a useful tool to have. The second is looking at the assumption, and it's quite an important assumption, that the completeness is uniform by age or constant by age. Third is looking at the problem of trying to estimate completeness of adult mortality by subnational aerial units, like provinces and the like. There's a problem with using vital registration household death data. And then lastly, just a brief look at some research that we're doing into estimating mortality at advanced ages. So South Africa has a population of now about 55 million, 52 million at the census, and in 2011 there were about 500,000 deaths, but that's come down from a peak. We have still a significant HIV/AIDS epidemic, but in recent years we've had significant interventions, particularly into retroviral treatment. And I've mentioned the other background already. But one of the other issues is that the most recent reliable estimates of infant and under 5 mortality come from the 1998 DHS and the 1996 census. Censuses and surveys subsequently have failed to produce reasonable estimates, and so that makes it kind of difficult to check completeness of child mortality. Okay, starting off with the rapid mortality surveillance system. There was a hiatus in the processing of VR data in South Africa that coincided with the rise in the AIDS epidemic. I'm not suggesting that was the reason for the hiatus, but clearly there wasn't a strong drive at the time, given the government's position on HIV/AIDS to improve the system later. Now, as you know, we have a population register with all registered births and adults with IDs. We set up the rapid mortality surveillance system, getting the data from the population register on a monthly basis to attempt to prove, versus commas, to the government that people were in fact dying of AIDS, and to track the impact on mortality over time. And I think it had the desired effect. Not immediately, but over time, of changing the government position, along with a lot of other efforts by other people. But more recently, we've been using the system to track the impact of the intervention, particularly into retroviral therapy. And essentially, what we do is we look at the relationship between the numbers in the population register, the numbers of deaths, and the vital registration, and the trend in those ratios by age over time, and then use that trend to convert the population register data into what we would expect for vital registration. Separately, we are estimating the vital registration data, the completeness of deaths 15 and above, using intercentral periods, putting a trend to the completeness over time. And for the under 5, we bodged together some estimate of the completeness of death based on the whole host of estimates of under 5 and infant mortality that we've got, on the assumption that completeness, by and large, is monotonically increasing unless there's a specific reason and a particular time for it not to do so. So here is the ratio of the population registered numbers of deaths by age to that in the vital registration. The low blue line is those are under age 1. As I mentioned before, there's a selective effect happening there, and the births aren't being registered because the deaths, they die before registration. But from age 2 onwards, you can see there's been a rapid increase in the proportion. And in fact, so much so that from 2008, it looked like we were starting to plateau, and so we had a nice, healthy trend that we could follow and project to get a more rapid estimate of what then the vital registration data was presenting. However, if you look at the top line, the deaths over age 25, you'll see that actually it jumps to 100%, and in fact, in the last 2 years, it's over 100%. Now, if you remember, the vital registration data is all death notifications, and the population register are only those with IDs. So, mathematically, the ratio should never be above 100%. And so there's clearly a problem with the system. It's been around for a number of years, even when the total for 25 plus was below 100%. At the advanced ages, it was over 100%. And we thought it probably had something to do with the ID, the birth on the death notification form only have two digits for the year of death, and hence there were probably some children being classified as being over 100 or vice versa. But that's got steadily worse. And from about age 55 or 50 onwards, there are more deaths on the population than existed in the vital registration. So it's flagging an issue there. And so that's one of the benefits that arises from having a population register, is that it can highlight when something's going wrong with the vital registration, capturing of the death. On this slide, what we're looking at here is taking our estimate of what we think is the true number of births, and hence the implied completeness of vital registration. What's measured on the x-axis is duration since the calendar year of death. So you'll see over here, it took about 2 years before they released data, vital registration data, and then in the more recent years, they've tried to accelerate that until it's 11 months now, when the first reporting of the death. And then you have late registrations coming out with each new report. So looking at that, you'll see for the earlier years that you have a plateauing around about 93-94% in that region. The completeness of your vital registration against whatever that estimate of the true number is. And then for the most recent 3 and possibly 4 years now, it looks like those data are going to be plateauing at a lower level. So suggesting that completeness has actually fallen by 1 to 2%. And this is quite useful to know if you're trying to estimate your mortality. The rapid mortality also estimates the under 5 and infant and neonatal mortality. The solid lines are the estimates from vital registration correcting for incompleteness. The dotted lines are year-on-year estimating the vital registration from the population register and then correcting for incompleteness. And you'll see right up to 2011, they match very well. So it was a very good predictor of your vital registration over time. And then in the recent years, the vital registration data are less complete, in part because of late registrations that are still to come through, than the population register. So the population register is probably giving us better estimates now than the vital registration because of both the late registration and the drop in completeness. Also included on this graph are represented by a dotted line here. There's also a dotted line you can hardly see there, which is doing a direct calculation, taking the vital registration deaths under 1 divided by the births registered up to 1 year after the year of birth, showing you that it happens because the completeness is roughly similar, that you get a pretty good estimate simply directly from the data. And so when completeness is at the high levels for both birth and death, you could actually do the calculation directly. And then lastly, there's a dashed line here, which is using the information from the district health information system, neonatal death divided by the birth system. And it's of the right level. It was low here because the system wasn't quite complete. Interestingly here, it's giving a higher estimate of neonatal mortality than one is getting from the vital registration and for the population register. And we don't know why that is. Moving on to the question of whether completeness is uniform by age. This is from a paper by Lee Johnson et al. And it's actually linking, but I didn't want to have a third session just for the one graph in the linking session tomorrow. And it's basically the data from the population register were linked to patients attending health clinics, getting antiretrovirals from health clinics, and in particular to try and track whether patients that had been lost to follow-up had in fact died or not. And it gives an estimate of completeness, showing that the completeness actually falls for the younger adults. So for the older adults, it's not unreasonable to be assuming about 40 onwards, maybe even a bit younger than that. But for the younger adults, particularly the male, it's a drop in completeness. There's also a difference in completeness, and this will apply to many countries, a difference in completeness between urban areas and rural areas. And if you have a difference in the age distribution, as one often has between urban and rural areas, then it's impossible to have uniform completeness by age for the country as a whole. And in South Africa, that's particularly so when you look at the population group, because there's some that are highly urbanized and others that aren't. Lastly, when you're looking at data, deaths reported by household in the census, you have a problem in countries where there are many one or two person households, because very often the death's not reported. The household, if it's only one person, there isn't a household to report it. But quite often, if it's a two-person household, the second person may well not stay in that household. Death doesn't get reported. In South Africa, we have an additional problem for particularly the white population group, because they go to old age homes, so you can capture those deaths either in the household survey. There could also be a problem for young adults in that they may not have established themselves in their own unique household, so they may be staying away from home, but still be considered part of a household, so you get double reporting of the death. Turning now to the estimating mortality by provinces or regions, and we have a challenge, because if you use vital registration data, there's often a lack of correspondence between the place of death and the place of usual residence, and the systems tend not to record usual residence, or if they do it only for very recent years, and probably incomplete. And you have a problem that you need estimates of migration to produce, or estimates of mortality, and the migration is far more significant as the subnational level. And for household deaths, as I say, the assumption of constant completeness by age is often violated, and also the deaths cover a fairly short period, creating uncertainty. And so what Ian and I have been experimenting with is combining both data sources using the vital registration data to estimate the true number of deaths nationally by age and sex, and perhaps any other division that could affect the reporting by household data. In South Africa, we use ethnic groups because households be very different by ethnic group. And then you make the assumption that the households by sex and any other division are equally likely to report deaths at each of the ages. So there's no reason why a household in one province would be reporting the deaths any differently from another province. And we've applied the method in South Africa. Problem, of course, is we don't have a gold standard against which to measure whether it works. We use orphanhood data, and there's a reasonable correlation with orphanhood data, but of course orphanhood data itself is problematic, because parents don't necessarily live where the respondents live. And there's a lot of problems in trying to get mortality rates in an HIV environment from all this data. Here I've shown a comparison of our estimates against estimates from a model. This is a model taking into account the impact of HIV/AIDS. And of course, quite a lot of the mortality we're dealing with is HIV/AIDS and the different levels of prevalence in the provinces. And it shows a scatter around the 45-degree line, and a ranking that is not unreasonable in that the bottom provinces, the lowest provinces of Western Cape and Gauteng, and Limpopo are known to have low mortality, and the top provinces, KwaZulu-Natal has the highest HIV prevalence and quite high rural population. Eastern Cape is also rural and very poor. So there's a consistency in the ranking. We also looked at data from Brazil, and Bernardo was kind enough to provide us with his estimates. And so we had the unique opportunity of comparing independent estimates using household-only data and independent estimates using vital registration-only data against our system of combining the data. And for the household data, if you look at the 45 to 15, you'll see that where we've got a marked difference between males and females, and a fairly narrow spread between in the mortality between regions for males and for females. The estimates that come from household-only data are far more spread. There's a greater spread, which means that you don't get quite the distinction between males and females spread in regions. And most of this is due to the estimate of completeness. As you see, we have, because of the assumptions that we're making, a fairly narrow difference in completeness, whereas estimating completeness on the household data directly produces quite a wide range of estimates by region. When we look at the vital registration data, and I have to confess, this isn't an application of the death distribution method to the regional data combined. It actually was to the state data, and I've derived regional estimates by the weighted average from the state. But what you see is a far closer approximation to estimates that we've got. Huge distinction, a difference between the mortality of males and females. And when we look at the completeness estimates, they lie fairly close to the 45-degree line, certainly with the possible exception of the south region, within the bounds of uncertainty of the methods. And then lastly, looking at the problem of estimating mortality at advanced stages, and part of this work was to try and look at whether there's been an improvement in mortality at advanced stages. This shows an estimate of mortality at the advanced stages, correcting for incompleteness in reporting, but no other correction. And it's not an unfamiliar pattern. You find it in developed countries as well, where the mortality doesn't rise as fast as one thinks it should at the older ages. There's sort of a leveling off quite often. But it is quite extreme, and it's, of course, largely due to the age exaggeration census data, exposure data. But there's also other data problems that are apparent. This shows for males the census in blue, census count numbers by individual ages, and you can see this definite digit preference. It happens to be year of birth, digit preference, so 71, 81, 91, etc. Are preferred because of the rounding of the birth data. But you can't really see it, but there are some other years as well, 1914 and 1918 for some reason. Clearly, were you born before the World War or after the World War, and so that's apparent. And so what is done in the developed countries is that method called the near extinct generations method, which is really just a refinement of or extension of the extinct generation method, which says that people of a given age must all die. That cohort dies also over time, so if you can count all the deaths, you know how many people were alive. Near extinct generation just says we don't want to wait that long, so we'll estimate the few that die in the next 10 years or so at the advanced stages. Application of the near extinct generation methods in South Africa more or less reproduced the census data with all its digit preferences, telling us that the digit preference is actually in the death data, in the official IDs, in fact, as much as it is just reporting in the census. And so it wasn't much help in getting rid of the. It was a lot of help in getting rid of the age exaggeration, but the digit preference, it wasn't much help. Now it turns out that the near extinct generation is akin to something that actually is used called the runoff triangle for estimating claims that have been incurred but not yet reported. So you've got existing claims, and you can work out what claims are going to come down the pipeline. And actuaries have extended the runoff triangle into using generalized linear models, and we've been working with that, and in fact extending it a bit further with a generalized additive model, which is sort of a generalized linear model with smoothing, which does remove a lot of the heating. And has produced, these are preliminary results, mortality rates that are shown, just showing males here. The national rate slide here, this is the white population, the African fly close to the national, this is the colored population, which is not exactly what one would expect unless you believe that one, the mortality is selective, and the high mortality early on and very long-living people in the population, and a comparison of our national against the maximum, minimum, and average from the human mortality database, suggesting that we've still got a problem. I don't believe there would be that switch over in mortality rates by population group, and the trend still looks too flat. And I suspect that there's some age exaggeration in the death data that we haven't quite accounted for. Okay, so RNS, the point I made this morning, even an incomplete population measures that can be useful. And when completeness is high, then direct estimates of IMR is probably not too inaccurate. The assumptions of constant completeness by age only true for the advanced ages in South Africa, likely to be a problem in any heterogeneous population, urban, rural, but there could be other reasons for it. And household deaths are likely to be problematic unless you've got stable, multi-generational households. And I think it's quite a challenge to produce reliable results using deaths reported by health census. In terms of subnational populations, I think the method is promising, but we don't have a gold standard to check. And it works better if you can identify factors that will be linked to whether a household was reported death or not. And so that might be useful work done in that respect. In terms of the mortality of old ages, there are problems here of birth heating in particular. Can be entrenched in the official data. So the assumption that your death data would report age, for example, better than a census report doesn't seem necessarily to hold. And the generalized additive adaptation of that NEG method has potential. But I think we need to do some more work on that. Thank you.
Thank you, Rob. Okay, last session. National and subnational experience in estimating the extent of threatening completeness of registration tests in Brazil. Bernardo.
So, this is a guide work with Everton, and the main idea we have here is to analyze the completeness of depth count coverage in Brazil and its regions inclined to 80. We compare different approaches using depth distribution methods and data source, and then some discussion on the importance of evaluating data quality, and also in the end some discussion on how demographic methods can be combined with statistical methods to produce small area estimates. So this is just brief discussion, and this builds on a lot of work with Everton, Flávio, and Marcos with him. So the main idea, as we in this whole afternoon, is a very small percentage of countries have complete vital registration systems, Therefore, mortality estimates are very limited and demanding general application of demographic and statistical methods to obtain proper estimates of life expectancy, for instance. And this is important because mortality estimates are necessary to keep track of development goals. The effective data affects public health planning and population forecasts at local and national and subnational level. And in the case of Brazil, there is a significant improvement in the last few years, but there is still a wide variation of data quality and progress in data quality. So that's our main idea. So why the case of Brazil is interesting? There's the availability of data and it's public available. So we can get mortality data basically from 3 different sources. Census data only 2010, that includes the question household deaths, and also the 1980 census. But the main difference is in the 1980 census, household deaths were included only in the long questionnaire, and the 2010 was in the short questionnaire. So all the households respond to this question. And the 1980 census is not available easily. And death count, you can get from vital registration system and from the Ministry of Health database. They come from the same event, but they go to different directions, and the Ministry of Health database is more reliable than the vital registration system. The main thing is that after death happens, you get the document. That document in the health unit goes directly to the secretary of the local secretary of the health department, and from there goes to the Ministry of Health. And with this document, you can do the funeral and everything else. And then if you want to, for the vital registration system, you need to go to an official notary public and do the bureaucratic work, and this goes to the National Statistical Office and then goes into the vital registration system. In addition to that, the Ministry of Health database contains the database. You can download it, and you can download out the database contained by each line is the death. So it's, instead of having aggregated data, you can get the actual events. And the actual events include age, sex, where it happened, the city, in some cases the zip code, the ICD, and some other characteristics, occupation, educational level, but those are quite poor. So for some areas they're pretty good, for some other areas they are not very good. So this morning there was a discussion on the issue of privacy, data in 5-year age group and something. So far we don't have this issue. So you can go to a presentation and you can get to Fernando de Noronha, it's a small island in the northeast. And between 2009 and 2011 there were about 12 deaths in 2010, and you can get this data and see what happened there. So this is the kind of data we can. Brazil is also interesting because the population is large and it's distributed in a large territory with huge income inequality, different trends in demographic and epidemiological transition. So this gives opportunity to study small area estimation problems and issues. And in recent years, there's a huge increase in understanding levels and trends of demographic data at the local level. So I use data from the vital registration system from IDG, I'm not showing here, but the Ministry of Health database. You can download the data there, the statusfood.gov.br. You might need to know some Portuguese, unfortunately. Yeah. And IDG population census, both population and death counts. Actually, the Ministry of Health database, there's an R package now that helps you to work with the data, and most of the descriptions in English, so it helps a lot. It directs you to the link where you have to download the data, so it's easier to. And the IDGE population census, to get the population and death counts for 2010, I'll compare with the. So a little bit on the methods, I'm not go. We apply all the variants of the death distribution methods, the country, state, and smaller areas for each pair of interstitial periods. I'm showing results for the Meso region. They are comparable areas, and they stay comparable from 1980 to this year. So Brazil now has 5,580 some municipalities. In 1980, there were 3,000 municipalities. So to organize that in one database is quite troublesome. The same city is divided in 2 or 3, but we use those 137, but we can do a smaller area, comparable smaller areas that we can compare about 2,500 from 1980 on. So we use the variations of the BDM for more details. We did that just before. And some of the results here are using the raw package that was developed by the team at the Max Planck, Ederson, and I. And the idea of the package is to run, it runs all the variations of BDM with different age range and kind of produce the best estimate. So we can have different estimates using different age ranges and different methods for different areas. So I'll go to the results now. So that's the Brazilian data book using the Ministry of Health database from 1998 to 2010, males and females. Completeness for males is a little bit better than females, and we see a steady improvement in the completeness of test count coverage. We reached the most recent years to 98% completeness for males and 96% for females. Different studies using similar methodology arrive at quite similar results. So in recent years, there's a lot of improvements and investments from the Ministry of Health trying to improve the collection of information, and it's reflected in the estimates that we are able to produce here. And one nice thing that one could do is the 2010 census includes the question household deaths that Rob just showed here, and it asks also age and sex of the deceased. For the universe responded to this question. So instead of being a sample, it's the whole universe. And then we evaluate the quality of the information for the country, and with a colleague, we evaluate the data quality for the 27 states. And one interesting thing that's being done using the census data is to investigate mortality differentials. So there's some studies on the mortality level by education, income level, and some focus on young adult mortality difference. But the main thing we found was pointed by Rob just now. So this is comparing the census data in the blue line and the Ministry of Health database in the red line. And the main thing we can see is what's happening. This is just for males. It's what's happening in the young age. So census data reports a little bit more deaths than vital statistics. Probably the main thing is that the same death is being reported by 2 or more households. Over 3/4 of those deaths are caused by external cause. So probably it's a very remarkable event. And even if the young adults living outside the home, probably his parents are also reporting this. So there's like homicides and stress accidents, most of those deaths. So that's but for the other age groups, we see pretty much good results, even going to age 80 and plus. So this is an interesting thing we found using the census data, except for these. But then, for the national level, it improved consistently over last few decades, several investments from the Ministry of Health and other agents, but improvements are not homogeneous over space. So we show estimates of death count completeness for males, Brazilian states, this is 2,000, so this is database. Darker, so 26 states plus the Brazilian. Darker parts of the map are the better regions, the lighter ones are worse data. So São Paulo has pretty good completeness. Minas Gerais are in front. Brasília, this one here, Rio, and the South. And then when we go to 2010, which is the whole South and Southeast, with pretty good completeness, and some parts of the Northeast, and then the northern part of the country has the lowest level of completeness, but still much better than 2000. So this is strongly related to improvements and for investments in the Ministry of Health and other approach to improve the collection of mortality data in Brazil. And then we go one step further, and we compare those 137 meta regions from 1980 to 2010. Here's for males, from 1980 to 91, 91 to 2000, 2000 to 2010. So each year, here is one region of within the state. And then we see in the 1980s, the southern part of the country has better more complete coverage than the other part. And 1991 to 2000, we see improvement of the collection of data. And then in the most recent years, some areas with low coverage, but very large parts of the country have a good estimate. So one key point here, we do a three-step adjustment. We don't apply just the best distribution methods directly, because for several those regions, they might be really small, so there's a lot of fluctuation on the mortality age profiles. Our first step is to smooth it, and then we did a simple way using indirect standardization. Then we apply the best distribution method, and then we developed a care factor so the level of the small area level is not the same as the neighborhood area. So it keeps if it's lower, it stays lower than the neighborhood. If it's high, it stays higher. If it's the same, it stays the same. So this one thing it's an area that needs more research. But then I'll show some results that's quite interesting. And we do the same for females, and it's pretty much the same figure for the state and similar figure for the males. South and southern part of the country with a much better coverage than the northern part, but signs of improvement throughout the country over this period of analysis. So one question that might rise is the assumptions might be violated in small areas. So migration is it's a big issue. Also the way we estimate and all the other possible violation of assumptions. So we perform simple analysis. We add up the estimated dash counts for each small area and compare to what we obtain at the state level. And then we compare adding up all the things with the country level. So that's what we get. So this kind of this should be instead of it's a little bit more. So the red line should be right in the 1, not in the 90 something. And the blue bar is 1980-91, the red one 91-2000, and the gray one is 2000-2010. So the same procedure was applied for each one of the periods of time and for each region of the. And what we see is the less populated states with worse data have more problems when we apply that distribution method based on age. When we go to São Paulo, for instance, this one here, it works quite well. If we go to Minas Gerais, it's a large state, it works quite well. But then we go to the Northeast, so for instance, Rondônia, it's a tiny state in the Amazon, it's more problematic. Maranhão, which is known for the state in Brazil with the worst data quality, and several other data issues and several other issues. This is where the procedure works the worst, doesn't work very well. But this the one check we did to see what was going on was making sense. And then we produce estimates of the 45Q15. I'm not showing here, but they have when we compare the state level and the progress of the country, we see that they're quite reasonable, higher mortality in some areas, and where one would expect higher mortality levels, we find higher mortality levels, where one would expect lower mortality, we find lower mortality. We managed to get the increase in young adult mortality over the 19th to early 2000s, so it's a quite promising approach, we believe. Just closing, so we see remarkable regional difference on completeness of death counts and adult mortality of the last 3 decades. Quality of death count registration in the country is improved over time and across country. Methods seem to work very well at the subnational level, and the results we obtain from other regions are quite promising, even using traditional demographic methods. The main limitations are migration flows that violate one important assumption, that we deal with it in a very simple way. So we produce the estimate of completeness ignoring the young age that have both flows and zero case. So zeros might be not an event, but zero also might be an event that wasn't reported. So we have to deal with that. So that's the thing we are dealing with. Improvements seem to be close associated investments in public health, the public healthcare system, and administrative procedures to collect vital statistics. So there are huge efforts from the central and local government to collect data, to improve data quality in Brazil. So, and one example that is always cited is the Brazilian Family Health Program. That is a local health program, and each municipality has one or more teams of family health programs that have more control of the people that are living there, and this also helps the quality of the information. And also in the case of Brazil, the Ministry of Health and the Ministry of the Public Pension System, this was this data is not public available, not that I know. But one problem that the Ministry of Public Pension had people that died and kept receiving pensions, not the person, but the family. Yeah, because so they matched the data. So they matched the public pension data with vital records and public health, because they have the name of the persons and all the information, and they managed to find several problems of people receiving benefits after that. And this also, some people were trying to get this data for a really long time to study mortality at older age, because supposedly the information they can bring a match using the vital records, the data schools with public pensions to improve the quality of mortality data at older age. And one thing that is important, data, in the case of Brazil, the data being public available is very helpful, and also the experience with the census questions was quite useful to some additional studies and to compare with the vital registration. And in more recent years, we have some people working on methods to estimate mortality at smaller areas, local level, city level, a little bit. So with Everton, we use different statistical methods to estimate mortality at the city level. And Marcos Gonzaga with Carl Schnetzman, they proposed a method to estimate mortality curves at the local level. They just presented at the Alatia meeting a couple of weeks ago. And it's a moving standardization regression model process, and one really cool result they found that the standard they use doesn't matter. So any standard they use seems to work quite well. And the same authors as both, they developed alternatives to estimate completeness by age group using Bayesian statistics. So this is one area that we believe it's a relevant area to work with instead of using as one factor for the whole, for adult mortality, but if we're able to obtain different adjustment factors for different age groups would be an improvement, and this also would help to study mortality at the local level. So
Thank you, Bernardo. Okay. We have minus 1 minute for discussion. I think a couple of points stood out. I think several of the presentations